Hey everyone, continuing with our polynomial rational functions, we'll be looking at a example where we have a oblique asymptote, and it's going to be a slightly extreme example. We have a cubic function on top and a quadratic function below in the denominator. So let's say we have x cubed plus 2x squared minus 3x plus, let's say 1 over x squared minus 3x minus 4. Alright, so just like the previous video, we have to do our long division. So you can pull out your long division sign, or what I'll do is I'll do it by hand, and I'm kind of going to go through how I'm going to do it by my eyes. Alright, so firstly we have our x in our quotient because our coefficient of x cubed is 1. So x cubed, we can just ignore that for now. So we have minus 3x squared, which will become plus 3x squared. So we have 5x squared. Right, 2 minus 3 is 5. Then minus 4x, so minus 3x minus 4x will give us x, right? So we have 5x squared plus x plus 1. I'm just write it down for all of you here. So that means we have 5 as our second part of our quotient. And now we do the same thing, giving us 16x plus 9. Sorry, not 16x. Yeah, 16x. What am I doing? Minus 21 plus 21 rather, because now it's 5 times minus 4, so 20, 1 minus 1 is 20 over, now we factorize the denominator, x minus 4 and x plus 1. All right, so from here we can put our asymptote, which is always at the quotient after our long division, just like the previous example, but instead of horizontal asymptote we get a oblique asymptote at y equals to x plus 5. I'm going to draw the asymptote at the bottom here. We then have a vertical asymptote at x equals to minus 1 and x equals to 4 because we cannot divide by 0. As such, we have x equals to minus 1 and x equals to 4. Okay, I'm going to extend the asymptote a little bit because the graph is going to be a bit different. Alright, now, one interesting that you might take note of is that it's gonna be very different from the usual graphs, right? You had a linear denominator, but when it comes to a quadratic denominator, the graph is slightly different. I'm gonna go through that one by one, right? There'll be 3 parts to this graph. The first part is before the x equals to minus 1, all right? Now, x approaches minus 1. This approaches minus 4, this approaches 4, this is positive. This approaches 5, so this is 0. So x plus 5 is still positive, 16x plus 21 is still positive as x approaches minus 1. The denominator, however, x minus 4 will be negative because x is still negative. X plus 1 would also be negative. As such, this whole thing would be positive as x approaches minus 1. And as x approaches minus 1, this will be very, very, very small, hence giving you a very large number. As such, our graph would look something like this on the left side. Of course, I'm kind of shaking a little, so I'm gonna try my best to get very close to the asymptotes. So this will be the first portion of your graph. The next portion would be between x equals to minus 1 and x equals to 4, your 2 vertical asymptotes. And your graph will look something like this. You'll get a turning point at x equals to 0, I assume, and then drawing it downwards. Of course, you need to solve for your your turning point, which will involve some calculus, I assume, and there we have it. That would be the turning point, right? And it's x at x equals to 0, I think. Whatever, I don't think so actually, but yeah, there's a turning point. But yeah, I'm just draw it better. Something like this, right? But yeah, I mean, it kind of touches the x-axis if I'm not mistaken, but yeah, that is how it is. All right, do use your GC. Then the third portion of the graph will occur at above x equals to 4, and you notice that above x equals to 4, you start to get affected by the asymptote, oblique asymptote, and it looks something like this. All right, very similar to that for the left portion of the graph, but it'll look something like that. All right, with the same idea that as x approaches infinity, y will approach infinity as well, and it will look like a V shape. All right, So there we have it, the quadratic sort of graph, and obviously maybe, you know, I never really draw it perfectly, especially for this middle portion, but that is kind of I hope it make do. All right, basically there'll be three portions of the graph: the left side, the middle portion, and the right side for a denominator that has a quadratic function.